Hello, I'm Urania, the Greek muse of astronomy, and I'd like to help you with your revision of the astrophysics option in the A-level physics specification. You may also find the following book useful: The A-level Astrophysics Workbook, by Dr. G.K. Fox, exclusively available in the Kindle store. It also happens to have a picture of me on the front. In this video I will review the ray diagram for a refracting telescope, in normal adjustment. Drawing the ray diagram of a refracting telescope, in normal adjustment, is a map from memory technique. To draw the ray diagram, we first draw two converging lenses. We can draw them as actual lenses, or we can represent them by double-headed arrows. In normal adjustment, the object is at infinity, and the image is a virtual image, at infinity. By having the image at infinity, means the eye is relaxed. These conditions are only met when the focal point of the objective lens coincides with the focal point of the eyepiece. Once we have drawn the lenses, we label the focal point with a capital F. We now draw three parallel rays from the object. The first ray we draw passes through the center of the lens, and continues in a straight line until it reaches the eyepiece. In order to continue the ray through the eyepiece, we must first draw a construction line that passes through the center of the lens, and coincides with the ray where it passes through the focal plane. We can now continue our first ray through the eyepiece, drawing it parallel to the construction line. We now draw a second ray above and parallel to the first. As the second passes through the objective, it changes direction, refracts, and coincides with the first ray at the focal plane. On passing through the eyepiece, it is again parallel to the construction line. A third ray is now drawn parallel to the first two. Again, after the objective, the ray is drawn so that it coincides with the other two on the focal plane. After the eyepiece, the ray is drawn parallel to the other two. We now complete the diagram by drawing on dashed lines to show that the final image appears to be a virtual image at infinity. We draw additional arrows to show the direction of the rays, and we label the diagram using agreed conventions. Remember, this is called normal adjustment because the image is at infinity and so the eye is relaxed. It should also be noted that the image is upside down compared to the object. It should also be remembered that the three rays come from the top of the object, whilst the bottom of the object is located along the principal axis. The final image is said to be virtual, because it appears to be on the same side of the eyepiece as the intermediate image formed in the focal plane. Thank you for watching.